Hi everyone, welcome back to my tutorials. I like to do a video on areas. So area is a measure of the total square units enclosed by a polygon or other closed region. So let's take a look at some properties. All closed regions have areas. So this complex looking figure has an area. Congruent closed figures have equal areas. So if we look at these two like ice cream shaped figures, and that they're both congruent, then they both have equal areas. Areas of complex figures can be thought of sum of areas of simpler figures, partitions. So area of ABCDE, this complex looking thing here, is equal to the sum of area of ABCD and the area of BDE. Special areas. The area of a rectangle with length L and width W is area is equal to L times W. You can also write area is equal to W times L. The area of a square with each side of length S is area is equal to side squared. Example 1. Given ABCD is a rectangle, AB equals 5 meters and AC equals 2 meters, find the area of ABCD. So write down what we know. The area of ABCD is going to be length times width, so we can just plug in 2 meters times 5 meters equals 10 meters squared. Example 2, given ABCD is a square, AB equals 7 centimeters, find the area of ABCD. So write down what we know. The area of ABCD is equal to side squared, so it's equal to 7 centimeters times 7 centimeters equals 49 centimeters squared. Let's look at problem 1. Given length of AB equals 6, length of CF equals 10, length of AC equals 8, and length of EF equals 3, and we have right angles at the vertices. Find the area of this whole kind of L-shaped looking form. So write down what we know. Extend segment BD to point X where it intersects with segment CF. Segment CA is perpendicular to segment AB. Segment XB is perpendicular to segment AB. And segment AC is perpendicular to segment CF because perpendicular segments meet at right angles. Segment AC is parallel to segment BX. If two segments are perpendicular to a third segment, they are parallel to each other. So we just showed in 4 that, these two segments are going to be perpendicular to AB, right? Segment AB, so they're going to be parallel to each other. Segment BX is perpendicular to segment CF. If one of two parallel segments is perpendicular to a third segment, the other segment is also perpendicular to the third segment. So angle X here is going to be a right angle. ABCX and DEXF are rectangles because a quadrilateral of 4 right angles is a rectangle. So we have this right angles at these vertices, right? And we showed that X was also a right angle. And we can just, we don't have to prove it's a parallelogram. We can just say if a quadrilateral has 4 right angles, it is a rectangle. We can use the area sum postulate to get the area of ABCDEF is equal to the area of rectangle ABCX plus the area of rectangle DEXF. We can do area of ABCX is equal to length of AB times length of AC. 6 times 8 is 48. We know opposite sides in a rectangle are congruent, and by the definition of congruence, length of AB equals length of CX. Length of CX plus length of XF equals length of CF by the betweenness properties of segments. Therefore, we can do some substitution. We know that CF equals 10, right? And AB equals 6, so CX is equal to 6 too. XF equals 4. So the area of DEXF equals the length of EF times length of XF. So 3 times 4 equals 12. So the area of this whole figure is going to be 48 plus 12, which is 60. This is going to be the last problem. Given a circle with center O and radius equal to r, we inscribe a rectangle ABCD. We're given that the length of side BD equals L, and we're given that line OM, so this thing here, is perpendicular to segment BD. Find the area of ABCD in terms of R and L. We write down what we know, and we know that side BD is a chord, right? Because it's a segment joining 2 points on the circle. B's on the circle and D's on the circle. We know it's on a circle because it's inscribed, right? So we know by this theorem, if a radius is perpendicular to a chord, then the radius bisects the chord. So we know OM is a radius and BD is a chord, and we know that they're perpendicular, so we know that M is a bisection point for BD, for segment BD. So in other words, the length of MB is going to be 1/2 of the length of BD, right? Because to bisect is to split into 2 congruent parts. So if you measure one of those parts, it's going to be, the length is going to be 1/2 of the entire part, right? So now we're going to draw a segment OB. Between 2 points, a segment can be drawn, and we know that angle OMB is a right angle, right? Because perpendicular segments meet at right angles. So triangle OMB is a right triangle, because a triangle with a right angle is a right triangle. We can apply the Pythagorean theorem, OM squared plus MB squared equals OB squared. We can substitute OB equals R, right? Because we know the circle has radius R. So we get OM is equal to square root of R squared minus L divided by 2 squared. And L divided by 2 comes from this statement 6, right? So, and we just square it. So technically it's going to be plus or minus the square root, but we can omit the minus because lengths are always positive. Okay, so we know that chord AC is going to be congruent to chord BD, which is another way of saying segment AC is congruent to segment BD, because ABCD is a rectangle, right? And opposite sides in a rectangle are congruent. We know if 2 circles in a circle are congruent, they are equidistant from the center of the circle. So in other words, this segment ON is going to be congruent to this segment OM. By the definition of segment congruence, the length of ON is equal to the length of OM. So in other words, the width of this rectangle is going to be equal to the length of NM, right? So, and that's by the betweenness property of segments, that's going to be the length of NO plus the length of OM. So since these two length of NO and length of OM are equal, right, we can just say width is equal to 2 times the length of OM. So we can rewrite this as 2 times what we had for OM is square root of R squared minus L divided by 2 squared. So the area of ABCD is going to be equal to width times length by the formula for the area of a rectangle. So area of ABCD equals 2 times the length times the width. So 2 times L times square root of R squared minus L divided by 2 squared. So that's all I have for you tonight. I want to thank you for watching, and I hope to see you during my next videos. All right, take care, everyone. Bye.